All right. Now, this is where it gets very powerful. Okay? Because once you've figured out the atoms and what they do and how they're going to behave and what their electrons are going to do, the protons make the atoms what they are. The electrons make them act the way they do because you never mess, you don't get inside of an atom. You just get, remember when I said the atom, if the atom was the size of a basketball, the electron would be 5 miles away?
Yeah.
Okay, because that's how much of an atom is empty space. If an atom, if the proton, if the nucleus of an atom was the size of a basketball, the protons were and neutrons were the size of a basketball, the electrons would be like little bitty mosquitoes 5 miles away with insane speed.
Insane.
Okay? That is what the atom is. But so you only deal with, you never get to the nucleus of an atom with chemistry. You only get to the electrons. And they change orbit. They might go 5 miles away to, 4.5 miles away or 6 miles away, or that's when they're jumping there.
How far could that go?
I don't know what the biggest atoms are out there. Maybe I'd guess 10 miles away. Maybe twice that far. That's a guess. Proportionally, All right. So when atoms, now these are all the things there are in the world. When atoms make stuff, it's their electrons that make stuff. So let's draw an atom.
In the world for now.
Yeah, that's all we know for now. So let's draw a simple thing: salt. Is there an atom of salt?
Yeah. Or not one, but you gotta mix them.
Right. There's no such thing as an element of salt or an atom. Salt is a compound. It's two kinds of atoms. So we take sodium, which is 1, 2, 3, 3 shells.
Sodium chloride is salt.
Sodium chloride. Salt equals sodium chloride. So we have sodium, 11 protons. I think it has 12 neutrons. And it has this little electrons here. It has, how many go in the first shell?
2.
2. You better know that, Zaylin. How many can fit in the second shell?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2 are 10. I need one more. So I have one like that. Now, sodium has one lone electron out there. How is sodium going to act? What's it going to do? It's going to try to get rid of that electron. That's a very loosely held electron. It's negatively charged. That's negative. That's negative. That's negative. It's got a negative cloud, and it's attracted to the positive down here. But man, that looks like a T. But it's got to go through these layers of negatives. So that's not held very tight. Look at chlorine, right over here. How many shells does chlorine have? Since it's in the third row. 3. So chlorine, and since it's atom number 17, it has 17 protons.
So they're mixed?
Hang on.
Mixed means they're next to each other.
Now, hang on, let me draw this. Let me draw chlorine. There's 2. 2 of the 17. I got 15 more. How many does the second shell hold?
15.
How many does the second shell hold?
15.
Oh, it holds 15 electrons. 1, 2,
Oh, no.
3,
No,
4, 5, 6, 7, 8.
It holds 6.
1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
Second shell holds how many?
6 because you used the 2 in the first shell, right?
But I have to get 17. So the first shell, I have to use 17.
The second shell is 15.
Yeah, I will usually fill these third shells. So I have 17 I have to get. 2 in the first shell, I got 15 more. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2 are 10. How many more to make 17?
7.
Right. So then watch this.
So
1, 2, 3, 4, 5, 6, 7.
How do you know how much should be on each one?
2, 8, 8.
Oh.
Because I don't have to do it. And you know what? Like I told you before, chemistry, can you imagine me saying, memorize all 100 atoms, I want you to memorize their names, how many electrons they have, how many protons they have, how many orbits they have, how they act, do they give, how many empty spot. That would be impossible. I don't have to memorize any of this because I have the periodic table lined up because scientists did it for me way ahead of time. Now watch this. This is what's beautiful. Look here. Chlorine has 2, 8, and 7. Has 17 protons, 17 electrons. That's a good chlorine atom. Sodium has 11 protons, 2, 8, and 1. That 1, now here's the deal. Chlorine desperately wants to take an electron and have a full shell. Sodium desperately wants to give away an electron and go to 2 full shells. They'd rather have 2 nice full shells.
Sodium.
Right there.
It's Na.
Yep. It's not S. It's not S like sulfur.
Yeah, that's what
That sulfur was taken S, so don't confuse that. So watch. That's a match made in heaven. The sulfur says, oh, gosh, I hate, if I could just get rid of this one electron, I'd do anything to get rid of this one electron. Chlorine says, gosh, I would do anything to get an electron. If I could just find an electron. Well, the sodium says, hey, take my electron. And the sodium now has 18 positive and 17 negative, so it's a positive 1.
Isn't that chloride? Or
You call it chloride when the chlorine mixes with something else. And then the sodium has 11 positive and, I'm sorry, I did that wrong.
Yeah.
Yeah, the 11 positive and 12, and now it has 10 negative, so it has a positive charge. And what happens to the positive and negative ends of a magnet?
They go together.
Right. So this sodium and chlorine now, and this is an
now
obvious.
one of them's negative and one of them's positive, so they go together, so they create salt.
Yep, and so that is salt, and the oceans are full of it, and it makes sense. And everything makes sense when you have a periodic table. That is why we have CO2. That is chlorine. That's what the chlorine molecule representative looks like. Okay, I have enough time. I could maybe do carbon and oxygen. Let's see about CO2. Ready?
C, so that's C.
C is 6.
C is, yes, C.
6
C
protons.
Is 6 protons.
6 neutrons.
And it has,
Since it has 6 protons,
it has 6 electrons.
how many fit in the first shell?
4.
How many fit in the first shell? Oh, that first shell holds 4. 1, 2.
2.
Okay. So 2 fit in the first shell. How many fit in the second shell?
4.
Yeah, they can hold up to 8, but 2 been used up. It has 6. So 1, 2, 3, 4. Look at that. How many does it want in that second shell?
In the second shell?
How many make it stable?
8.
3, 4, 5, 6, 7, 8. So it has 4, and it has 4 electrons and 4
spaces.
open spaces. Look at that. Now let's draw oxygen. 8.
Isn't it O2?
Hang on.
2 oxygens.
Yes. CO2. Let's look here what's going on. So you're going to have 2 in the first shell. 1, 2, 3, 4, 5, 6. I did that kind of terrible, but you get the idea. Now look at that. It has a gap here and a gap here, say. Same thing over here. One, 2, 3, 4, 5, 6. So it has a gap here and a gap here. Now look here. The oxygen and the carbon can say, oh, you know what? You use my oxygen sometimes, and I'll use yours, and you use mine, and I'll use yours, and you use mine, and I'll use yours, and you use mine, and I'll use yours.
So,
And those atoms kind of combine with each other.
that's CO2.
Just like, say, I need to, here, borrow my black marker and I'll borrow your red. And if you share, then we both can use them, right? Like
Yeah.
borrowing somebody's pencil. And that makes a molecule of CO2. Kind of like symbiosis in biology, true. And that is how molecules are made. And that's how stuff is made. And we can predict how all the stuff is made in the world because of its position on the periodic table. And we kind of know what ratios they'll go together. And we know what'll mix up with what. Okay? That is the periodic table. What lesson was that?
About how atoms form together to make stuff.
Yeah, was that the 8th one?
Yeah, I think so.
Yes. It's
Okay, that was lesson 8. That's about what I'm going to do today. And hopefully you kids can ask me questions on it when I see you.